Hey guys, it's Ben's Data Diaries again. Today I want to show you how to solve one of the most important equations in linear algebra, which is ax equals b. And I will do this using Python's SymPy library. So let's dive right in. First of all, check out the system of equations. Three equations we have here with three variables, x1, x2, x3. Here x1 is missing, so it's only x2 and x3, and here x3 is missing, only x1 and x2, three variables. So how do we solve this now using linear algebra? First of all, let me import SymPy and some config libraries that allow me to print the equations and the matrices. And we do this using SymPy by saying sp, which stands for sympy.matrix. And then we just use these numbers and put them in this format. So over here we have 1, 2, 3, just goes in here. 0, because this variable is missing from the second equation. 1, which is the x2 over here, and 4, this one. And the last row also 5, 6, 0. And the part after the equal sign will go into the vector, into vector b. So over here we do load the vector 7, 8, 9, corresponding to these numbers over here. So the first step to solve this equation is to basically just attach vector b to matrix A. And we can do this using a row join. So we say A, matrix A, row join this vector b. So I already put it over here, and you see 1, 2, 3, and the 7, 8, 9 is attached at the end. And then the next step is to perform row reduction to find the RREF, which is the reduced row echelon form. And if you don't know what this is, check out my previous tutorial where I went through these steps manually. But for now, we're using this function over here. So basically, we're taking this system over here and applying the RREF function. And the output of this operation will yield the reduced row echelon form, which has the identity matrix over here, as you can see. And the right-hand side, it has the result that we're looking for. So these values here are actually the solution to the system. And if we scroll down, you will also see that over here, we can then use this command just to extract this part here, which is the solution. So it just says, give me only the part here, -1 from the right-hand side of the matrix. And then this is the outcome, 21 minus 16, 6. But the standard method to solve the system using SymPy would be to use a function called linsolve, and goes like this. So first of all, here again, loading the matrices and the vector separately, and then need to define these three variables over here. So let's see if I've actually loaded it. I'm loading it again, and defining x1, x2, and x3 using this command, the sp.symbols, and define it as x1, x2, x3. And when I use the function linsolve with this system, so I'm giving it the matrix over here, the vector over here, and then the three target variables, x1, x2, x3, and it will hopefully yield the result that we are looking for. So this is exactly the same output that we can get just using this function, and this would be the normal way to do it. Hope this short tutorial was useful for you guys, and see you again soon on my channel.